So we have to move on to question number 2. So the question number 1 is typical but very simple general things that they have asked from you. But don't forget, the question is a little bit longer. This would be the trend from this 2017 onwards towards your 2020 paper, because what they have done is they have omitted some out of syllabus. I would say out of syllabus, little bit of going toward out of syllabus. They have avoided that, and but they have included more questions which are general, with including more calculation related. Okay, so don't forget that. Question number 2. So X, Y, Z are elements that belong to the same group in the periodic table. So it belongs to typically our same group. So we will consider what are these: X, Y, and Z. They are in 3 successive periods. So in fact, they are in 3 successive periods. So that is good. On descending the group, that's good. So Y exists as a non-metallic colored liquid. So you know, typically the non-metallic colored liquid belongs to group 7, and it is bromine. So this is bromine. So this should be then chlorine, and this should be iodine. So X is chlorine, Y is bromine, and Z is iodine, right? Indicate the relative magnitudes of the followings with regard to X, Y, and Z. So this is very typical, right? Because atomic size, so fluorine, chlorine, bromine. So iodine would have the highest, and then bromine, and then chlorine. Because on descending the group, you know, additional shell is formed. So according to that, it will be the. So electron affinity. So electron affinity means the ability to get an electron, right? So what do you think about this electron affinity? So you have iodine, which is very large. You have bromine, which is a little bit lower in size, and chlorine, which is very lower in size. So if this is size is very lower, so think about the attractive forces between the electron and the nucleus. It is very high, right? So when you want to add an electron, and these are all in group 7, so electron addition is favored. But when the atom is small, the effective nuclear charge is very high, right? So when you want to add an electron to this, still it will be very, very, very much favored, because there is a higher attraction to get that electron, right? So according to that, the order will be reversed, like chlorine and bromine is always in between, and then iodine, which is very large, would have the smallest one, right? So then the first ionization energy. So the first ionization energy is typically based on the removal of the outermost electron, right? So what do you think about the first ionization energy as well? So you know, when you go down the group, the shell is added, so the outermost electron is far away from the nucleus. So this would be the easiest one to remove. So the lowest would have again iodine, then it would be with bromine, and then it would be with chlorine, right? So share it again. So this would be the trend, okay? Right, so this is the first part is done. So we have found the elements very quickly just from this little statement. So you are provided with aqueous solutions of the anions of X, Y, and Z in each separate test tube. So you will have separate test tubes, so no problem with the contamination. So suggest a single reagent that could be used to identify. So the single reagent that you can use is AgNO3, right? So silver nitrate. So if you add silver nitrate, you have to mention the observation. So for X means chlorine, so there will be AgCl. So we can write down AgCl, white color precipitate is formed. Okay, you have to mention that white precipitate is formed. And to Y, you can identify Y and Z. So this is AgBr, So this would be AgBr, which is a light yellow precipitate, right? So this is light yellow. Okay. And finally, AgI would be dark yellow. So don't forget, this is dark yellow. AgI. AgI would be dark yellow. Right. So this is what you can mention, right? But don't forget, this is not the only experiment that you can mention. Even you can mention the Cl2 CCl4 test, right? Because you know, in the organic phase, when you have this Cl minus in the organic phase, it would be like in the colors. The organic phase is colorless. When you have bromine, the organic phase would be orange in color. And when you have iodine, the organic phase will be in purple color, right? So you can mention that one as well if you really smart, right? Because you don't have to write AgNO3. Okay, so this would be a colorless organic phase, orange color and purple. Give balanced chemical equation for the reactions of X2 with the following. So X2 means it's the reaction with Cl2, right? So Cl2 with ammonia. So what are you going to expect? That is what they are asking. So if you can remember, we have already seen this reaction before, because don't forget, chlorine with ammonia can form two different, in fact, three different reactions, right? Either it can form like N2 plus NH4Cl, because they have not given a good condition, right? So N2 and NH4Cl is possible. That is one possibility. Or either N2 plus HCl is another possibility. Or either NCl3 plus HCl is also possible. So you can write one of these three reactions, and you can balance. So balancing is very important. And that's it. Then with DIL NaOH, so diluted NaOH. So if you can remember, Cl with dilute NaOH would give one product should be NaCl, that is typical, and the other product should be the oxychloride, so NaOCl. And finally, there will be water as well. So that's those are the three products that you can observe, right? So draw the structures of two oxo acids of X. So now we are going only with this chlorine, right? So chlorine, you have many, so you can use to write HOCl or HClO2, HClO3, or even HClO4. So you have all these oxo acids of chlorine, which can be used to draw here. So HOCl is a normal single bonded oxygen, and oxygen to hydrogen and oxygen to chlorine is single bonded. And HClO2 chlorine will be there. Chlorine is bound to OH group, and the other oxygen will be a double bond. So that is normally what present. And others are very typical things. So you can draw very simply for these two, right? Name one natural source of X. So X is chlorine, is naturally present in where? Seawater, right? So you can see this in seawater. That is a normal question, right? A monomer that contains X forms an addition polymer. Okay, so a monomer that contains chlorine, what is it? According to that, it should be PVC, and it is mentioned here. See, manufacture of water pipes. So PVC, you know, there should be a double bond, and instead of one hydrogen, it should be replaced by using a chlorine. So this is the monomer of PVC, right? Write the full name of the polymer. So full name of the polymer is polyvinyl chloride, right? So that's it. So then we are moving on to part B of this particular question. So part A, you see it is not hard, right? So typically it's a very easy question that you can follow, right? So don't forget about the things that you can get from these questions, right? The pattern is a little bit changed, but still, if you are complete with your concept, so you can go through it. Right, so an aqueous solution Q contains 3 anions, and the following tests were carried out to identify these anions, right? So these 5 tests were carried, and we will check what are these 3 anions. So we need to find. A diluted HCl was added, and a colorless gas was evolved, and a clear solution was obtained. So 2 observations are given. So normally when there is a dilute solution, a colorless gas means typically it can be either CO3 2 minus. So now it should be very familiar, right? Then it's CO3 minus, or either SO3 2 minus, right? So these are very typical things that you can identify from these. Others, it can be S2O2, S2O3 2 minus if it gave a precipitate also, but they say it is a clear solution, right? The gas evolved was, so this will give CO2, and this will give SO2, right? So this is +4 in oxidation state, and this is also +4, right? The gas evolved was tested with filter paper and moist with lead acetate, and there is no color change. So typically this gives the idea this is not H2S that is formed, because H2S also can be given, right? If you can remember. So this is not this, because if it gives this with lead acetate, it will form either like this is a typical example of a precipitate, but here with lead acetate, lead acetate should be formed, right? So it is lead acetate, so it would be forming the PBS, and but they say there is no color change, so typically there should be not any reaction that is happening. That is the idea, right? And so from this, what you can see is it could be either maybe this one or this one, CO2 or SO2, which means either carbonate, bicarbonate, or sulfate. Okay, sulfite. And we will go to test number 2. So barium chloride solution was added, a white precipitate. So it could be either barium carbonate or barium sulfite. So still no problem. The white precipitate was separated by filtration, and also don't forget. So we are talking about these two, but we don't know what are the other anions, right? So we have to think about that one as well. So what can be the other anions that can be present? Like here, there can be like I minus and all those things. But for this, typically when you add barium chloride, we normally think about sulfates and sulfides, so 3 2 minus, and even carbonates. So these 3 can be, because this is a white precipitates. The white precipitate was separated by filtration, okay, and diluted HCl was added. A white precipitate dissolves with the evolution of a gas. So what do you think about this? They have filtered, and then they have added HCl. So if this forms barium carbonate, and if this form barium sulfide, so if you can remember, I have discussed many times, when you have barium sulfide, we typically add HCl. When you have an acid, it dissolves, right? So with an evolution of gas, so this should be SO2 again. Okay, so don't forget, some amount is dissolved. The gas evolved was tested with a filter paper moist with acidified potassium dichromate. a color change occurs. So this confirms this is not CO2, this is SO2, because this is +4, right? So it can oxidize up to +6, while this potassium dichromate can give a color change from orange, which is +6, to green, which is +3. That's the overall idea, right? So one anion from these two is confirmed. So this is SO32 minus, that should be present. And the second is concat NO3 and excess ammonium molybdate. So now they are adding a little bit of ammonium molybdate. So to check whether there are some phosphates formed, ammonium molybdate is generally for that. So no formation of yellow precipitate. So forget about this. And there was alloy and NaOH solution were added, and the mixture was heated, and a gas that turned Nestle's reagent. So typically they say ammonia is evolved, right? So I told you this specifically, this test is used for NO3 minus. So we have found the second anion, that is NO3 minus. And ferric chloride added and a blood red solution is obtained. So if you have Fe3 plus, we have discussed this in my D block also. This will combine with SCN minus to form the complex. So we have found the 3 anions now. So these are the 3 anions that we have here: SO32 minus, NO3 minus, and SCN minus. So identify the 3 anions in solution Q. So these are the anions: SO3, NO3, and SCN. SO32 minus, NO3 minus, and SCN minus. Write the balanced chemical equation for the reaction taking place in test number 2-3. So test number 2-3 is this. So you can typically write this one as far as we have discussed. So SO2 should go towards SO42 minus. So you can balance here by adding 2H2O here, because 2 oxygen is missing. So you can add 4H plus here for this one. And then you can balance the charge by putting, I think, 2 electrons, right? Yeah, this is balanced. And meanwhile, your dichromate solution, which is Cr2O72 minus, should undergo reduction to chromium 3 plus, right? So you can balance this reaction. This is also common now. So you can balance this 2 chromium, 7H2O, and then 14H plus. So you don't have to write these things here. That is what I wanted to explain. You don't have to write this in the small space given here, the 2 balance half reactions, and you multiply these electrons, and you don't have to do this here. We have asked just the balanced chemical equation. So you can do these 2 in the rough sheet, and quickly you have to only write down the balance overall reaction. That is fine. Okay, so that's the overall idea. So don't forget about that. Right, so we are done with question number 2 as well.